if you go into this GitHub link under the folder pipeline and read the README markdown file, you would see the overview of the architecture. It actually is a combination of our method 1, which used toggling, and then did the validation with my PyMU PDF, and the method 2, which took an image of the page and then did OCR and created the chunking. So it merged together both and created this a prototype architecture where the entire thing is kind of controlled within our code, not using any third-party models for the extraction part. The pipeline is designed to be configurable. If you look at our method 1 video, you would see the considerations which were put in. Basically, it can handle both the malaria, WHO PDF content, as well as the Uganda clinical guide content without having to change any code. And then we have this extractor PY, which uses a multi-pass PDF analysis, and I'm going to cover the multi-pass very shortly. Then we have the validator PY, which does the consistency scoring of those extracted content. The idea is if the scoring is low from the source to the knowledge base, it will not even bring in the content, and it will flag it for manual review and then adding it through some manual intervention. And then finally, we have the chunking. It uses a smart semantic indexing where it's a section is tied back, even though they are broken down into smaller chunks, it's tied back to that main section. And finally, there are some guardrails, and I'm going to cover these shortly. So we have 4 different guardrails. We're right now trying to ground this the prototype. And finally, there's a Q&A, which is the interactive side of this application, where the end users or the health workers at Uganda are supposed to interact with and get responses. In the extraction stage, we have 5 parsers. The first parse analyzes the profile of the page. Parse 2 extracts the text. Parse 3 extracts the tables. So it's not stored just as the text. The table content is not stored as a text, rather the entire structure of the table is retained. Very important for this use case because there are some drug formulation dosage details which come in the tabular format here. And then parse 4 is the cross-validation. And then the final parse is for the images. So any images, flowcharts and diagrams which are there in the documents, we save it as independent images. The validator engine is, like I said, it determines the threshold, whether the source can be extracted and converted into our format into a knowledge base. And we have a confidence level. If it fails in any of these sections, it will be flagged and sent for human review. Finally, the chunking. It uses structure splitting, so the content of that section is all together. And coming to the guardrails, we use 4 different guardrails at this time in the prototype. Again, just to make it clear that in our following weeks, we will be finalizing the areas beyond the chunking. But this method I've gone through and created at least a baseline for us to start with somewhere on the following sections of our pipelines. So the guardrail. The first step of guardrail is scope classification. So any question which is not pertaining to our medical clinical queries falls out of the scope, so it's automatically refused. Confidence threshold. So when the responses are considered, it looks at the risk level and then the level of confidence in the response, and based on that, content is either generated or it's blocked. And the application can handle the response with recommendation for a human medical professional response for that question. A grounding verification, and then the constitutional constraints are the next two guardrails we also have applied in this prototype. So high level, again, walking through the orchestration layer, the Q&A layer, which talks to the user or works with the user. So the user query comes into the Q&A.py layer, and then it calls queries the index to retrieve the top 5 results, and the guardrail brain then verifies the results to make sure it's matches those 4 guardrail principles, or rather passes those 4 guardrail principles, and then finally you get the output. Now, when we ran the cross-validation, we found with the WHO malaria guide, we were getting almost like 82.7% consistency, and you can see the link of the report in this Markdown file, and the same telemetry for the Uganda clinical guideline source. Were actually giving us better results. So we kind of got like almost 90+% cross-validation consistency. Examples. For each, we kind of generated in this prototype 25 questions with 25 responses. Just wanted to highlight 3 examples here, how each layer kind of adds up to the final output. So in summary, the Method3 is an engineered option which has all the layers to check the extraction consistency, extraction confidence, and then during the Q&A, we have the guardrail placed in where, based on the risk and the response confidence, it will decide to provide a response, or rather route it to a human medical professional.